Hello friends, today in this session we will discuss simple cases of lines, how to draw projection of lines, and projections are known, how to determine true length, angle theta and phi, and what are traces of a line. So I will start with a very simple case, that we can say case 1, when line is parallel to both HP and V. So this is the horizontal plane, the vertical plane, and a line AB which is parallel to both the reference planes. Now when I say a line is parallel to a plane, what does it really mean? If I say this line is parallel to horizontal plane, it means the height of this end and height of this end is same. So when you project this line on vertical plane, the elevation of this point and elevation of this point will be the same. So A dash B dash here will be parallel to ground line, like this. A dash and B dash will be parallel to ground line because both ends have the same altitude, same height. Similarly, if this line is parallel to vertical plane, then this distance and this distance are same, and therefore the plan of this line AB on horizontal plane will be parallel to ground line. So A and B will also be parallel to ground line, like this. So if you complete this, you get these points, ground points. That is the A0 and B0, A and B. Now here, A dash B dash is the elevation of the line and AB is the plan. Both are parallel to ground line. Both are parallel to ground line. So in projection, when you draw the projection, XY is the ground line and elevation is parallel to ground line, and plan is also parallel to ground line. This is the projection of a line which is parallel to both HP and V. When this line is parallel to horizontal plane or vertical plane, you can see here, if a line is parallel to vertical plane, then you can measure this length of the line in vertical plane. So this is the true length of the line AB also. True length. And similarly, if it is parallel to horizontal plane, then you can measure true length in the horizontal plane or in the plan also. So this is also true. Now let us make this line inclined to horizontal plane. Let us say at angle theta. At angle theta. Now AB moves to this position, B, but still parallel to vertical plane, like this, like this. This line is inclined to horizontal plane at angle theta, but it is parallel to vertical plane. So that condition, that the line is parallel to vertical plane and therefore plan is parallel to ground line, still holds. But the line is not parallel to horizontal plane, and therefore the plan will not be the true length. Plan will not be the true length. But elevation will be the true length. Because this line is parallel to vertical plane, and therefore elevation will be the true length. So this will be the elevation now. This will be the elevation. A dash, B dash. And the plan will be here. This is small number, V. And if you complete this, this will be here. So in projection, what you see, that the elevation is now inclined and plan is parallel. A dash, B dash, A and B. This line This line is inclined to horizontal plane at angle theta, but parallel to vertical plane, and therefore this true length AB will be projected on vertical plane. So this is the true length, and this angle which is made by the line with horizontal plane can be measured in vertical plane. So this is the angle theta. Theta is the angle made by the line with the horizontal plane, and this is the plan AB. Plan AB. Now this is what is called the elevation difference. Elevation difference. That is the difference in height of two ends of the line. And this elevation difference is L sine theta. If L is the length of the line, theta is the angle made by the line with the horizontal plane, then this elevation difference is L sine theta. And this is what we call the plan length. Plan length. Plan length will be L cos theta. Similarly, if a line is inclined to vertical plane, line inclined to vertical plane and parallel to HP, like this. This line is parallel to horizontal plane, but it is inclined to vertical plane. This angle is called phi. Angle made by line with horizontal plane is denoted by theta, and angle made by the line with vertical plane is denoted by phi. So in this case, you can see that when I say this line is parallel to horizontal plane, that means the height of two ends is same, and therefore elevation will be at the same height, A dash, B dash, and this angle you can measure in the horizontal plane, right? So this will be inclined at angle phi, and this will be true length. Just reverse of this case. Here the plan was parallel, and therefore you could measure the true length in elevation and theta also in elevation. Here elevation is parallel to ground line, and therefore plan will be true length and true angle phi. Now this is again plan difference, which is equal to L sine phi, and this is elevation length. Elevation length, which is L cos phi. So whenever a line is inclined to any plane, there will be either plan difference or elevation difference depending upon the plane. Now these are four conditions: that when the line is inclined to horizontal plane, there will be elevation difference and plan length. When the line is inclined to vertical plane, the plan difference and elevation length. Now if these four conditions are satisfied simultaneously in the same figure, then in that case line will be inclined to both the reference lines. Like this. A dash, B dash, A and B. Now this is what we call L sine theta, and this is L sine phi. This length AB is L cos theta, and this is L cos phi. The plan length and elevation. The elevation difference, elevation length. Plan difference, plan length. This line, because this is not true length, because plan is not parallel to ground line. Here in this case, true length can be measured only when the plan is parallel to ground line. And this is not true length because elevation is also inclined. Elevation is also not parallel to ground line. So this is the line which is inclined to both the planes. Now, in the same figure, I would tell you the traces of a line. Traces of a line. See, I'll take this case first. Here is a vertical plane and this horizontal plane, and that is the line. Now, when you extend this line to meet the horizontal plane, now this point in the HP, that is called horizontal trace. So horizontal trace, HT, I told you in case of planes, HT and VT are two lines, one in horizontal plane, one in vertical plane, because two planes intersect in a line. But in case of a line, it will intersect horizontal plane at a point. So HT here is a point. So how do you get this point here in this figure? See, this is the elevation and this is the plan. So plan is here, elevation is here. So when you extend this line to meet the horizontal plane without changing the angle, with the horizontal plane, so what happens to the elevation? Elevation slowly moves towards the ground line. And the moment it touches the horizontal plane, this elevation will touch the ground line. So if you extend this elevation to meet the ground line, this is the elevation of horizontal trace, H dash. And when you are extending this line to meet the horizontal plane, the plan moves parallel to ground line, because we are not changing this distance. We are not changing angle, we are not changing the distance of A or B from the vertical plane, and therefore this plan moves parallel to ground line. So if you move this parallel to ground line, you get, this is called HT, horizontal trace. Horizontal trace is always on plan or extended plan. Same is the case with the vertical trace. Another point is in vertical trace. That is the line, the point where line intersects the vertical plane. So in this case, we had a line like this. Its plan is inclined to ground line and it is parallel to horizontal plane. So elevation is parallel to ground line. Now you extend this line to meet the vertical plane. Here, it meets here. And corresponding to this point in the ground line will be extension of the plan. So again here, if you extend this plan here, you get a point here, this is V, and you extend the plan, you get V. Vertical trace of the line. Vertical trace of AB. So vertical trace is always on the elevation or extended elevation. Horizontal trace is always on the plan or extended plan. And in this case, let us take a case when it is inclined to both the planes. So here also the same philosophy is used, same method is used, that to get horizontal trace, you extend the elevation to meet the ground line. So you extend the elevation to meet the ground line. Here, this point is V. This point is H dash, and a perpendicular here. Extend the plan. This point is the horizontal trace. Extend the plan, and this intersecting point is the horizontal trace. Similarly, if you want to find out the vertical trace, extend the plan to meet the ground line here, and then extend the elevation, you get the vertical trace. Vertical trace can be below ground line, can be above ground line. Horizontal trace can be below ground line, or horizontal or above ground line, depending upon the inclination of the line with horizontal vertical plane, depending upon the position, depending upon whether this line intersects vertical plane first and then horizontal plane, or it intersects horizontal plane first and then the vertical plane. So that is how we determine traces of a line if projections are known. True length of a line. How to determine true length of a line if projections are known. Let us say a line AB which is inclined to both the reference planes, A dash B dash AB. Projections are known and question is to find its true length, theta and phi, and also traces. Traces you can find, as I told you, from the projections. Now there are two methods of finding true length of this line. Remember these cases, and these are principal cases or basic cases when the line is inclined to a plane and parallel to another. This is angle theta and this is true length. And another case was when the line is inclined to vertical plane, then this is true length and this is phi. These are principal cases, basic cases. Now there are two methods of finding true length and angle theta phi in this case. One is what we call rotation method. Rotation of the line. This is the line which is inclined to both the planes. Make this line parallel to one plane by rotating it. So you can make this line parallel to either horizontal plane or vertical plane. So that this case converts to either this case or this case. So that you can measure true length and theta directly from the figure. So let us make this line first parallel to vertical plane. So we take this case, right? So this line, let us say this is A and this is B. So holding A and this position, you just rotate this B and make this line parallel to vertical plane without changing its height. Because when you change the height, angle will change. So we are not changing angle theta, we are simply making angle phi 0. Right? So from this position, you rotate this line about A and make it parallel to vertical plane. So when you are making it parallel to vertical plane, how the plan is moving? Plan from this position is moving towards vertical plane. So plan will become parallel to ground line. So make this parallel to ground line. So rotate the plan, make it parallel to ground line. Rotate this B about A, make it parallel to ground line. So you get the new point here, B1, this point. And because height of B remains same, as I told you, we are not changing the height of A, and therefore B will move parallel to ground line at the same height. Here, B1 dash. And then this will be the true length. True length. This is B1 dash. Compare this case with this case. Now A dash, B1 dash is inclined and AB, which you AB1 is parallel to ground line. So this will give you the true length and true angle theta. True angle theta. Similarly, to find out angle phi, you can rotate this line and make it parallel to horizontal plane. Rotate this point and make it parallel to horizontal plane. And when you are rotating this point, make it parallel to horizontal plane, you do not change this distance. It remains same, otherwise this angle will change. So in the second case, what we do, make this elevation parallel to ground. So A dash as center and A dash B dash as radius, you make it parallel to ground. And from this point, a perpendicular or a projector and B will move again parallel to ground line, and then this will be the true length. This will be the true length of the line. And this will be true angle phi. That is called rotation method. One thing you should remember that by rotating this line, we are changing the angles. and therefore this method cannot be used to find out the traces because trace will change. If you want to find the traces, you should start from A dash, B dash, original plan and original elevation. The second method is auxiliary plane method. Auxiliary plane method. Now in this method, instead of rotating the line, we take an auxiliary plane which is parallel to the line. And this method is simpler. Let us take the same case that you have a line AB, A dash, B dash, AB. Now we consider a auxiliary plane parallel to the line. And if you remember in the session of auxiliary plane, I told you that auxiliary plane, how to draw projection of a point on auxiliary plane. This is the inclined plane at angle alpha. And to draw the projection, you take the perpendicular from the elevation and take a measure of the plan. This distance here is the auxiliary plan. Auxiliary plan on inclined plane. And I also told you in that session that this distance does not matter because the point is this one. The projection is this one, A1. This distance simply indicates the distance of the point from the inclined plane. This is the inclined plane. A point is here. So this distance basically is the perpendicular distance of the point from the plane. But projection is here. Whether you take this plane here or here or here, this position will not change. So if you can draw parallel planes here, these are all parallel planes. But projection of this point on this plane is constant. So there will be a plane which is passing through this point. And if you have 2 points, you can draw a plane which will pass through both the points. So that will contain the line. So if you draw this line here, if you draw this line joining A dash and B dash, that basically represents an inclined plane passing through the line. Passing through line 2. And therefore, if you project these points on this plane, that will be the true length. A1, B1. This distance here and this distance here. I will again repeat that distance is always measured from ground line. From old ground line is xy to new ground line is x1, y1. This is inclined plane, and therefore we take this distance here and this distance here, and you get the true length. This case now is similar to this case. You can compare here. If this height becomes 0, A dash, B dash comes from the ground line. A dash, B dash is the ground line. Then plan will give the true length and true angle. So this is the plan which is inclined to ground line. And this is the true length, and this angle which you get here is phi. This angle. That is the true length. And when you extend this, what you get here, when you extend this on the elevation, you get the vertical trace. Remember that. So when you extend this and extend the elevation, you get the vertical trace. Because here we have not changed the line. We have taken a plane, and therefore this method gives you Tn, phi and Vt, all three. Similarly, you can take a plane here, either passing through AB, or you can also take a plane which is parallel to AB. Parallel to AB, right? And project this line on this. So this is small distance here. This distance is A, that is A1 dash, and this distance is B, that is B1 dash. and if you join it, it gives you the true length. Why true length? Again, you compare this figure. Now, this is x2, y2, which is your AVP. Compare with this. You have xy here. Plan is parallel. Plan AB is parallel to ground line. Okay? When plan is parallel, elevation gives you the true length and true angle. So elevation will give you true angle and true. This is theta. This line must be parallel to x2, y2. This is theta. And if you extend this A dash, B dash to get the horizontal trace, now because we have taken this parallel to line, so this is the horizontal trace. Okay, extend this to meet the ground line, and from ground line, the perpendicular, extend plan, you get horizontal trace. This is the horizontal trace. This is auxiliary plane method of finding true length, theta and phi. These are two methods. You can take any problem and try to solve. One more case which I would like to tell you in this session is when the line lies in profile plane. Profile plane, I told you in my last session that profile plane is a plane which is perpendicular to both the reference plane. You can watch lecture 2 on auxiliary planes to understand the concept of profile plane, and this is the plane which is perpendicular to both the reference planes. This plane. This plane is perpendicular to both the reference planes. Any line in this profile plane. This is the vertical trace and the horizontal trace of the plane. If you draw any line here, let's say I draw a line like this, AB, which is perpendicular to horizontal plane. Now, if you take any plane which is perpendicular to, let us say this is horizontal plane, this is a vertical plane, and you have a plane here or a plane here, which is profile plane. So, if you take a profile plane, you draw any line in any position here, its projections will always be on this line, vertical trace. Its projection will always be on this line, horizontal trace. And these vertical trace, horizontal trace are perpendicular to ground line. And therefore, whenever a line lies in profile plane, its projections will be perpendicular to ground line. So, this is the projection of this line. Take a ground line, xy. This is the A dash, B dash, and here is A. This is the true length also, because line is perpendicular to horizontal plane, so you can measure true length in the vertical plane. If you take a line parallel to HP, it will be just reverse. Let us take a line which is inclined rather than perpendicular. Let us take a line which is inclined like this. A. Now here also the projections will be on HT and BT. This one, A dash, B dash, A, B. This angle is theta. This angle is phi, made by the vertical plane, because here when the line lies in profile plane, theta plus phi will always be 90 degrees. You can draw the line in any position. So in this case, the projections will be like this, that you have A dash A and B dash B. But because the line is inclined to both the planes, this is not true length, but this is L sine theta. This is L sine phi. The plan difference and plan length are same because L sin phi is equal to L cos phi, L cos theta. This is the case here. The elevation length and elevation difference are same, L cos phi. You can draw this line in this position also. In this position also, right? And then draw the projections. Now, let us say CD. Again, the vertical trace and horizontal trace will also lie on the HT and VT of this line, of this plane. Because wherever you extend this line, it will always be in the profile plane, and therefore when it meets vertical plane, it will meet here on this vertical trace. When it meets horizontal plane, it will meet on this line HT. And therefore, VT and HT will also be VT, elevation, plan, HT. It will be in the same line perpendicular to ground line. So, how do we find? Method is same as we have done in normal case, that you take another profile plane which is parallel to this line. Take a profile plane. Project this line on this profile plane, measure this small distance here, larger distance for B, that is B1, A1, and this is the true length. This is the true length. For A, small distance, for B, this distance. Right? This is the true length. And this angle, again you have to compare this with this case. When A dash, B dash is parallel to ground line. See here, A dash, B dash parallel to ground line. This is the ground line now. Elevation is parallel, plan is inclined. So plan should give you angle phi. Okay, so this angle is phi. And because I told you in case of profile plane theta plus phi 90 degree, so you can measure theta directly in this figure. Trace you can find similar to this. Extend AB to meet the ground line. So extend AB to meet the ground line here, and then this is the vertical trace. To get the horizontal trace, you do same exercise in this part. Take profile plane or same profile plane, project the plan, get the true length and the horizontal trace. So friends, we stop here today. I will leave with 4 questions which you can try yourself, and I will discuss solution of these 4 questions in my next class. Thank you very much for watching.